All right, so let's take a look at how we can do an interface in C++. But now what we have is the blueprint version. So interface again is going to allow you to communicate without knowing each other's actual type. You just need to ask the interface to do the communication. Okay. All right. So let's take a look at how to do that in C++. I'm going to go to the C++ classes and then create a new class. Scroll all the way down. We can look for the Unreal interface. And next, I'm going to call this guy again trigger. Let's make it C_trigger interface so that it's going to be different, and create class. All right. So when it comes to C++, there is some waiting time for the creation of the class and compilation. All right, so basically it's gonna be the same idea, just using different kind of way, different language. Okay, so here we have this is the CPP file. Let's go to the header file of the interface. You can see it's already having the necessary things. One thing I want to change is make sure that it's able to be used in Blueprint. So I'm gonna change that to Blueprint type, so that Blueprint is able to use it. Okay, all those things are supposed to be just fun. Okay, and here is where, as comment says, where you create the functions. Okay, so this is basically where the same or the equivalent of in the Blueprint interface, where this list is. Okay, so now back here to C++, we can now start to do the same thing. I'm gonna go create a U function. Okay, just because I want to also be able to be compatible with Blueprint. So it has to be Blueprint callable. Okay, it has to be a Blueprint native event, or Blueprint either Blueprint native event or Blueprint implementable event. There is a slight difference in this case, but I don't think that matters in our particular case. So I'm just gonna use the native event. Category can be called, let's say, react to trigger. Okay. All right. And then I'm gonna say void, and then we can name the function. So maybe triggered, the same name as we have on the Blueprint version. Okay. All right. So this is going to be all you have to do. Just like in Blueprint, all you did is just declare there's a function, and you didn't do anything here. Same thing goes to C++. You just don't do anything here, right? Just have the function signature added in or declared. The actual definition has to be done in the one who implement this interface. Okay, so that's all we have to do in this interface. Now let's make sure that it compiles before we move on. So go ahead and click on compile. All right, while we're doing that, we can also take a look at where do we actually, you know what, we have to wait for the compilation because yeah, it's finished. So we go here and we have to go create a class just to be able to show you all how to do everything in C++. We're gonna go create an actor that actually implement this interface. So I'm gonna call this guy C_jumper. Okay, we have a BP_jumper. This time it's gonna be C_jumper. Create class. Okay, and because this is an actor, all we have to do is basically inherit that interface, and we override the function. Okay, but it's not going to be that simple. Okay, so what we have to do here first is publicly inherit the interface. So this is going to be the in this case, let's take a look at the name. It's IC_trigger interface. That's going to be the one we have to use. So here, go back to the jumper. We have to do that, and of course we have to have the header here. So include C_trigger interface. Okay, so that way we're able to actually inherit it Right, when that is done, then we have to go down to the bottom and create a public function, and we're gonna need it to be also a U function, just to be sure that it's connectable to Blueprint in case we need it. And then this is gonna be a little bit different. In Blueprint, we just basically implement that event, right? And here we have to not just use the same name of the function, but we have to add implementation in the end, a common practice. So what we have to do here, in order to get this one overridden, we have to copy the name of this guy and go back here to our jumper here, and the function name will be the same name added with its implementation suffix, and then we do override. Okay, so triggered, and then underscore implementation, and then override. That's what you have to do, and then you implement it. So let me double click to copy that, and back here to the CPP file, and we just implement it over here. So void AC jumper, and then that. And then what we have to do is do whatever we want to do. That's basically where the body of the event is, or this is where we, this is the equivalent compared to the BP version, the jumper, equivalent of what's gonna be here. Okay, event triggered is gonna be in our Visual Studio, this function. And what we do here is whatever we want to do. In this case, I want to jump it also. So I'm gonna do set actor location. Actually, I should be able to do the same function. Add word offset. Nope. I'm just going to do the thing I'm familiar with. So set actor location, and then we get actor location, and we plus the offset we want to add, which is going to be a vector, and I want it to be up, right? So it's going to be 0 for the X and Y, and it's going to be 100, exactly the same amount of movement. All right, so now we have implemented the actual body of the triggered function, which overrides the interfaces triggered. All right, and I also need a trigger, right? So back here, just to be able to have everything in the C++, I'm just gonna create also a actor for the trigger. So that's gonna be C underscore trigger actor, okay, and then create class. All right, that's gonna be another class we have to have. All right, wait for the compilation. It's always kind of like a bit annoying having to wait. So that's why I think that most of the times, if you're not doing super low level stuff, not seeing why C++ is that important to use, just because of the time. But eventually you may translate all your blueprint to C++, and I believe there's a way you can do that now automatically, and which is really cool. So anyway, so in the trigger actor, I'm gonna go actually try to create some necessary components. So we need the box component, ubox component pointer, and I'm gonna call this guy trigger volume. Okay, and then it has to know what a box component is. So forward declare that ubox component. All right, and then in the actual constructor, of course, in the CPP file, I have to include that, include the box components header file. So box component, right? So I'm gonna say trigger volume will be equals to create default subobject with ubox component as the template type. And then we're going to use, name it the same as trigger volume. All right. And then for the trigger volume, I'm going to say, okay, you set collision response to all channels, to be, I don't want that execution version of that. So set collision response to all channels to be ECR, actually ignore everything. And then we just tell it to only set collision response to channel, and come on, I don't want that execution version. Set collision response to channel. I'm gonna just tell it to do something with the pong. So ECC pong and ECR overlap. So that's gonna guarantee that it's only gonna overlap with the pong because we turn off everything and then turn the pong on only. And then we can, just to be safe, trigger volume, set collision enabled to be query only. Just query the overlapping event. That's all I want to do. And then we do the on-component begin overlap. Basically, we're doing exactly what we're doing in Blueprint now in C++. So trigger volume on component begin overlap dot add dynamic, and then we're gonna add using this guy's AC trigger actor namespace and then a function. So to be able to get the function to have the correct signature, we have to take a look at this on component begin overlap. So we have to go to the implementation of it. I'm using a plugin, so I can just go there real quick using some shortcut, and that's actually the actual type. And let's go there. I can see it's actually a multicasting delegate. It's a macro. So I just need to copy the actual signature. If I can just select all these guys, and hopefully I'm not selecting these. So try that again. Okay, Control C to copy that. And back here to the trigger actor, I need to implement a function with that signature. So a public U function, it has to be a U function to be able to work. I believe it doesn't return anything. So void triggered or overlapped is going to be making more sense or more accurate. So overlapped, and then oops, I think I'm not copying that anymore. So try this again. Copy the signature and back here to the header file and paste that in. Okay. All right. And then we have to delete the comma because it's a macro. It does use comma between the type and name of the argument. That's the comma I need to delete. All right, so very long signature, but you can just copy paste. And then I'm gonna implement that. This time I'm gonna use shortcut again. Just this shortcut will actually create the implementation for me in the CPP file right away. Okay, the plugin I'm using is Visual Assistant. This one, really helpful. Anyway, so now we have the overlap function. Now I can actually add dynamic to that overlap function here. And what this does is basically call this overlapped function when on component begin overlap event got triggered. Basically, in other words, compared to what's happening in Blueprint, this on component begin overlap, and that execution pin will call something, right? And that something is going to be bounded to now overlapped function. So when on component begin overlap calls or runs, the overlap function will be called over here. Okay, and that's where we can start doing our whatever we're doing also in Blueprint, right? What we're doing is basically ask the trigger actor to be triggered using the interface call. In this case, we have to also, let me go back to the header file, and we have to have the actor, right? So U property, because we want to define it in the editor, so it has to be added anywhere, and Blueprint read write and the category equals to whatever. So trigger actor maybe. And then we can create just a actor pointer. Trigger actor. All right. This is going to be exactly how we actually add a variable in the trigger over here, right? That's the same thing basically. Now we have this actor now. Now let me go to the overlapped function, and that's where I need to ask this actor to do the interface call. All right, to do that, what I need to know is that if this actor actually implement the interface. Okay, so what we have to do is get the actor, so triggered actor, and then get class, and then when I ask this class implement interface. Okay, and we have to pass in the interface, and this time the interface has to be, and back here to the interface header, you can see we actually have two classes. We have to use this one, not this one actually. So I'm going to copy that, and back here to the trigger actor, I'm going to ask this guy's static class. Okay, so this basically will ask the trigger actor, are you implementing this interface? Okay, we have to do that in C++ to do this, and because we are using that particular class, we have to include the header of the interface. So trigger interface. Okay, so that way this will all be recognizable, and this will return true or false based on if our actor here is implementing this trigger interface. So we need to wrap it around an if statement. Okay, so let's say if it does implement, then what we do is we have to ask the interface to call the function. Okay, so to do that, we have to do the I trigger interface, and then we call this one's native execute triggered. Okay, you can see it's also a different function. The function we actually implemented in the interface is just called triggered. But when we were implementing on the one who used this interface, here, the jumper, it has to be this triggered underscore implemented. And when we're calling it, it has to be also a different name. The name will be the, let's see, execute underscore trigger. So it's three different functions, but it's the same thing. So I don't know how Unreal works the magic internally to actually hook those all up, but that's not our business here. And this function actually also takes an argument. The argument will be our triggered actor. Okay, so that's going to be the thing you have to do in order to actually call the interface function. So what's going to be happening here is that when we overlap with the trigger actor, it's going to ask if the triggered actor actually associated with is using this interface. If it does, call the triggered function, and the triggered function will be the one we created in the jumper here, which will move the jumper up 100 units. Okay, so that should be all the hookup we need to do. So let me go ahead and compile this. Okay, as you can see, doing this in C++ takes always more than twice as the time. That's my experience. Just because the syntax and the typing you have to do, and I'm already speeding things up because I'm using Visual Assistant to help with a lot of auto-completion. Now imagine typing everything from scratch very carefully, letter by letter. That's going to take even longer. All right, so that should be everything we need to do to actually have the C++ version. So let me go ahead and close this guy. Now we don't have any visual for these guys, so I'm gonna go create a blueprint version of them, but just for the purpose of adding the visual. So I'm gonna go create blueprint class for the trigger actor, and I'm gonna call this guy BP C trigger actor, so to indicate that's actually inherited from the C++ class of that. and create blueprint class. And this one I need to add the visual, so static mesh here. And then it's going to be again a cube, and I'm going to drag it down and flatten it and make it just a bit smaller and drag it up and compile it. All right, I'm not going to do anything else, just the visual. So that's going to be this guy and the other guy, our jumper. We're going to go create blueprint class for this guy also, and BP C jumper. All right, and also just the visual, so static mesh, and then cube, and that's it. All right, you can take a look at the class settings. You can see it's already inheriting the trigger interface, right? Cool. So now I'm gonna drag this guy in. Maybe I'm gonna drag it to the other side of the screen or of the character, so that way we can see both Blueprint and C++ version. They should be identical because I'm using identical functions. All right. So now for this guy, I want to pick our BPC jumper. Okay, and let's take a look. I'm going to go ahead and play and run here. You can see now it also jumps. Okay, but all the internal function is done in C++. We just add the visual to be able to see them working. Okay, so as you can see, we got exactly the same result in both C++ and Blueprint using interface. Okay, our C++ interface can also be used on Blueprint. Let's take a look at that. So here, I'm gonna go create yet another folder here. I'm gonna call this guy BPC interface test, just to be able to do some testing here. And I'm gonna delete everything we're having here because those are all working. I don't want to cause any confusions. Let's delete them all. All right, so I'm gonna go create a new Blueprint class, and it's gonna be an actor. Call this guy BP pure, be pure means Blueprint pure Blueprint class. I'm gonna call this guy jumper. Okay, it's another jumper here, and this jumper, I'm gonna make the class to actually inherit the one we created in C++. So this is gonna be the C trigger interface. Okay, so it's actually using not a Blueprint interface but a C interface, C++ interface, but itself is actually a pure Blueprint. Okay, so here in the event graph, we can still do that triggered event, and this event, as you can see, it's from C trigger interface, right? That's not from our Blueprint. And just to make things simple, I'm gonna go add word offset again, and then we'll offset it on the Z direction 100 unit. As you can see, if you can do it here, I think, and there's not a lot of performance hit. I don't think there's a lot of performance hit when you do this in Blueprint. Right, so I do encourage Blueprint more than C++ in some of the cases. Anyway, so let me compile and save this. All right, and then we can also create a new Blueprint class and actor, and call this guy BPure trigger. Okay, and this BPure trigger will just have a box collision and a static mesh as the visual. Same old stuff, real quick. Okay, and then on the static mesh or box here, we can do on component begin overlap, and then we do cast to pong, and then we go create a new actor object reference variable, make it public, call this guy triggered actor. Oops, triggered actor. And then compile this guy. I'm going to ask the triggered actor to do the interface call. So triggered, we're going to use the one This one is targeted C trigger interface. That's gonna be the one. So triggered. All right. So this is gonna be two blueprint that uses the C++ version of our trigger interface. Okay, and let's see if this works. I'm gonna drag this guy over here, and then the jumper over here. Forget to do the visual of it. So I'm gonna add a static mesh and make it a box, and that's all there is. Okay, go ahead and play. Oh, also I have to make this guy pick our jumper and go ahead and go there. You can see it jumps up, right? So that means the interface we created in C++ is compatible with Blueprint classes. And not only that, if I go ahead and delete this trigger, okay, and then just go ahead and use the trigger we created in C++ class, that should also work. So I'm gonna go drag the trigger actor here. And although we don't see a visual, but maybe I can just drag a cube here so that I know that that's gonna be where the trigger is. Okay, and this trigger is even able, or should be able to also trigger this jumper. So let's take a look at that. As you can see here, so a C++ versions of the interface call can call the interface function in the Blueprint version as long as they're using the same interface. Okay, cool. So they're all interchangeable, and it's up to you to structure your system so that you have your version of where you use Blueprint and where you use C++. But after all, the benefit of using interface is that the classes doesn't have to know each other, but they can communicate just by using an interface. All right, cool. So that's going to be the two videos to talk about the interface. Thanks for watching. See you next time.